This is paper 1, November 2014. So, question 1. Anna wants to know the colours of cars in the school car park. Brian wants to find out what students think about school dinners. And Carl wants to test people's reaction time. And they want you to say which one of these things here they should be using. So choose the method each person should use. So if you were wanting to know the colours of the cars in the car park, you would just go to the car park and look at the colours in the car park. So that would just be an observation. So Anna's would be an observation. And then if you're wanting to know what students were thinking about the school dinners, you would need to give them a questionnaire. So Brian's would be a questionnaire. And then the last one, testing people's reaction time, you would need to carry out an experiment. So the last one would be an experiment. Question 2, you're given 6 quadrilaterals. The quadrilaterals in the exam didn't have these diagonals drawn on. I've drawn them on because of the first question. So the first question says, write down the names of the 3 quadrilaterals that have diagonals crossing at right angles. So I drew on the diagonals going diagonally from one corner to the other to see which ones actually crossed at right angles. So the square does, the kite does, and the rhombus does. The other ones don't cross at right angles. So your 3 answers: square, kite and rhombus, and it doesn't matter which order you've got them in. Then part B, 3 of the quadrilaterals, the square, the rhombus and the parallelogram, and it says that the parallelogram is the odd one out and they want you to give a reason why. So I've drawn out just wee mini pictures of them here. The main reason is just that parallelograms don't have any right angles, whereas the squares and rectangles have 4 right angles, like 1 in each of the corners, and parallelograms don't. They've got 2 acute angles and 2 obtuse angles, so that would be the main reason for that. Part C, 3 quadrilaterals are rectangle, parallelogram and rhombus, and you want to tick the one property that these 3 quadrilaterals have in common, so something that they've all got that's the same. So the first one then, all 4 sides are the same length. That's only true in a rhombus, not for a rectangle and a parallelogram. You can see there that they've got some longer sides and some shorter sides, so don't tick that one. Then all 4 angles are equal. That's only true in the rectangle because it's got 4 90s there, whereas in the parallelogram and the rhombus the 4 angles aren't equal. Opposite angles are equal in those shapes, but all 4 angles are not the same. Diagonals bisect each other. I had the diagonals drawn on the first page of the question. So in a rectangle and a parallelogram and a rhombus are the ones that we're looking at, and the diagonals bisecting each other means that they cut each other in half. So that is the same as that, and that's the same as that, so they do bisect each other. And the same with the parallelogram. That wee bit is the same length as that bit, that's the same as that, so they bisect each other. And the same with the rhombus, so that is the same as that, and that's the same as that. So bisect, it doesn't mean that the diagonals are the same length, it means that they cut each other in half. So that is the property that they all have in common, so that's the box that should be ticked. So diagonals bisect each other is what they've all got in common. And then 2 lines of symmetry, just to check that one. A parallelogram have no lines of symmetry at all. Everybody thinks that they do, but they don't. They have rotational symmetry of order 2, but they have no line symmetry. A rhombus has 2 lines of symmetry, the diagonal lines, and the rectangle has 2 as well, just going down and across, but it doesn't have diagonal lines. So it has 2 lines, it has 2 lines, parallelograms, no lines of symmetry. Right, question 3. So here's the net of a cuboid and the net shows the area of each face, and you're wanting to work out the volume of the cuboid. So before you work out the volume, you need to work out what the 3 dimensions are: the height, the length and the width. So just looking at these numbers here then, I looked at the 15 and thought, what 2 numbers multiply together to get me an area of 15? So 3 and 5. And then if that side is 3, that one would be 3 as well, because when they're folded up they'd meet each other. And then 3 times the 4 would get you an area of 12. And then it works out okay for that 20 in the middle there as well, because it would have 5 down there and 4 across, and the 5 times the 4 gets you the 20. So the 3 numbers on the sides of the cuboid are 3, 4 and 5. So I showed a wee bit of working out there, just where the 15 would come from, where the 12 would come from, where the 20 would come from. I stated that the 3 sides are 3, 4 and 5. And then the volume for a box like that, for a cuboid, it's just your length times your breadth times your height. So these multiplied in any combination. So 3 times 4 times 5 would get me 60, and then the units centimetres squared, but they already had the units there, so you don't get a mark for that. Okay. Then question 4. The manager of a leisure centre uses this question in a survey. So how much time do you spend taking exercise? And then these are the options for the person to tick. And we want to write down 2 things that are wrong with the question. Well, first of all, there's no time frame given, so it should be something like, how much time do you spend exercising each day or each week, or something like that. So how much time do you spend taking exercise? It's a bit vague. Do they mean each day, each week, each month, each year? So I would just say for that one that there's no time frame given. The other thing then is that there's an overlap at 1 hour. So if you did exactly 1 hour of exercise a day or something like that, you would be able to tick both of those boxes, and you wouldn't want that. They'd want them only to be ticking 1. And then also there's no more than 4 for the people who do more than 4 hours. And as I said, they didn't say whether it was each day or each week, so it could very easily be more than 4 hours a week or something that the person would be wanting to tick. So just a mark for each answer there then. Number 5 says you will need a ruler and compasses to answer this question. Construct the angle bisector of angle A. So bisect means that you're wanting to cut it in half, but you have to use a compass. So you would do this. You get your compass and open it out to whatever distance you want, and then just keep it like that for the whole question. And you do a wee arc over the top of that line. Notice I put the wee pointy bit down here where the 2 lines meet at A. So do a wee arc over that line, and then go to the other line at the bottom and do a wee arc over it. And then where your 2 arcs are, here and here, that's where you now move your compass to, and do some arcs out in the middle. So like that. So pointy bit here, arc out in the middle. Go to the other one, pointy bit here, arc out in the middle, and then just get your ruler, which I maybe should have had sitting out on the desk, but I don't. Nope, no ruler. So I'm going to use my protractor just. Lucky they have a straight bit, and rule my line. Okay, and then actually the protractor will come in quite handy because I can check that I've done it right, that the angle is actually cut in half, if I've done it accurately enough. So it was about 70 there, nearly 70, so it should be around 35 or so, and it is. Alright, so you can check that at the end if you want to, just to make sure that you have actually cut it in half. So that's your angle bisector then. Right, question 6. Expand and simplify this. So for the first bracket, so you're expanding first of all, so multiply everything in the bracket by what's in front. So 3 times x gets you 3x, 3 times the 2 gets you the 6. Then you go to the second bracket, 2 times x gets you 2x, 2 times 1 would get you the 2, and that plus stays as a plus, that plus stays as a plus, and that minus stays as a minus. The only time that minus changes is if there's a minus out here, which would then change that minus into a plus. Okay, so that's what I've got at this stage. And then you actually need to simplify. So put the 3x with the 2x to get you 5x, and put the 6 with the take away 2 to get you the 4. and then just put them both back together again at the end. So expand, get rid of the brackets by multiplying, and then simplifying just means put the x's together, put the numbers together, and then write them down. So 2 marks here, you'd get a mark for expanding and a mark for simplifying. Question 7. So 3 electric cars are tested by driving them around a track until the battery runs out, and the table shows some information about their performance, and they want you just to complete the table. So car A goes for 4 hours, and the average speed in kilometres per hour means they travel 35 kilometres in every hour. So 4 hours, and they're doing 35 kilometres each hour, so do 4 times 35. And there's my sum down there for that. You could do it in your head if you wanted. There's only 3 marks for this, so it's only a mark for that, a mark for that, and a mark for that. But I did a wee sum down there. So 35 times 4 gets me 140. Then B, you're wanting to know 40 times what would get you 180. So do 180 divided by 40. And again, I've got that down there. This was without a calculator, this paper, I think. Yeah, without a calculator. So 180 divided by 40. I divided it by 4 first to get me 45. But I'm wanting to divide by 40, so I need to divide that by 10. So that's why it turns into 4.5. And then this one, 3 times what gets you 150. You could probably do that one in your head, or do 150 divided by the 3 to get the average speed was 50 kilometres per hour. Or you could do it all using this wee speed, distance, time triangle, but I just used it like thinking about it logically. If this is the time that they've got and that's how far, or sorry, yeah, this is the time that they've got and that's the speed that they're travelling at, so just multiply them to get the distance. Or down here, it's the same thing. Wanting the distance, multiply the speed by the time. So for question 7b then, wee bit more complicated this one. So 2 cars are driven around a 10 kilometre track, and both cars leave from the start line at the same time. Car X travels at exactly 40 kilometres per hour and car Y travels at exactly 30 kilometres per hour. How many minutes will it be before they pass the start line together again? So you need to work out how long it takes them to go round the 10 kilometre track. So for each car then, car X, if their speed is 40 kilometres per hour, so 40 kilometres per hour, and you trying to work out how far it would, or how long it would take them to go 10 kilometres. So just to go from 40 down to 10, divide by 4. So take the hour and divide by 4, and that would get you 15 minutes. Okay, so just thinking about it logically, again, I'm not even really using this triangle. So 40 kilometres in an hour means it would take them 15 minutes to do the 10 kilometres, so that means that it's 15 minutes around the track. Then do the same thing for car Y. Their speed was 30 kilometres an hour, so they go 30 kilometres in 1 hour, so 10 kilometres around the track. Do 30 divided by 3 to get the 10, so do the hour divided by 3 to get the 20 minutes. So that means that it takes them 20 minutes to go round the track. So this one goes round it every 15 minutes, this one goes round it every 20 minutes. So then over here I have car X and car Y, and kept going up in 15s and going up in 20s until I found the time that they actually had in common, and then that will be the time that they are at the starting line together again. So it would be 60 minutes, so they'd have to travel for an hour before they'd come back together again. Right, question 7, nope, question 8. So the table shows the length of the forearm measured in centimetres and the height for 10 people. So they're measuring the length of their arm and their height to see if there's any comparison between them. So a scatter diagram of the data is shown opposite, so the scatter graph is over there. So question 8a, another person has a height of 145 centimetres. Use the scatter diagram to estimate the length of their forearm and show clearly how you find your estimate. So use the best fit line. Go over to the graph, go to a height of 145, although I don't think they had the best fit line drawn on for you. No, we had to draw that in. So I always draw the sausage shape around the crosses, just so that it's easier for you to see what angle the best fit line should be going if you draw the sausage and then slice the sausage in half long ways. So use the best fit line then. A height of 145, it was quite awkward to find actually, so 150 would be in there in the middle. So 145, you're going across right in the middle of a square, and it says for you to show clearly how you got your answer, so you really need to show this line to show that you knew where 145 was and you didn't just guess. So across to the best fit line, not just to the sausage, and then down. And again, the scale was a wee bit awkward, so it's going 20. Then leave 2 wee squares before you get to 21. 2 more wee squares before you get to 22, then 23, 24, 25. So for me, I was getting it between 21 and 22. You mightn't get exactly the same as that. It depends on how you draw the sausage shape and how you draw the line. What they're looking for there is that you were able to find 145, that you knew to go across to the best fit line and you knew to read down. They would accept any answer in or around here, provided that your best fit line was okay. So back over here then, I put 21.5 for my answer. Right, 8b then. An approximate formula connecting the height and the length of the forearm is this formula here. Choose a person from the table and test the formula. You could choose anybody. I chose person A. And it just asks you, does the formula work exactly, yes or no? So depending on the person that you choose, sometimes it works, sometimes it doesn't. So I went back to person A, and their forearm had a length of 11 and their height was 108. So I put F equal to 11 and H equal to 108 to see whether it worked out or not. So if F is equal to 11 then, you would be doing 4 times 11 plus 60 to see if you get 108. So there's the 4 times the 11, 44, plus the 60 gets me 104. So no, it doesn't work for person A, because it should be 108 according to the table. So I ticked no. But you could have picked anybody there. There's a few of them that it does work for. It just depends on which person you choose. Right, question 9. So a small building company has 10 employees and the table shows their monthly salaries. So they've got a few labourers, a few drivers, a few supervisors, well, 1 supervisor and 1 manager, and then that's what they get paid. What is the modal monthly salary? So the modal means the most common. So if you look here, the modal monthly salary would be for the labourers, because there are more labourers than any of the other ones. So because there's more labourers, their pay is the most popular pay. So just 1 mark for that. Part B, the median monthly salary is £1,300. Explain why. So I went back up to here and put them all in order. So 5 labourers. I did, first of all I should probably say actually the median is the one in the middle. So I wrote out all the salaries and found which one was in the middle. So 5 labourers at 1,200. So I went 1,200, 1,200, 1,200, 1,200, 1,200. So there's the 5 labourers. Then 3 drivers at 1,400. So there's 1,400, 1,400, 3 of those. And then 1 supervisor, 1 manager. And then stroke them out like that until I got what was in the middle, and I ended up having 2 in the middle, that one and that one. And between 1,200 and 1,400 is 1,300. So the median is in the middle between 1,200 and 1,400, so that's why it's 1,300. It's only for 1 mark, but I just decided to write them all out so that I could show exactly that 1,300 was in the middle. But if you've just said this bit, if you just said that the median means the middle and it's between 1,200 and 1,400, that would be okay. Right, part C, the mean monthly salary is 2,620. Give a reason why the mean is not the best average to use for the 10 employees. So I put for that one that the manager is getting paid so much more than the other people that it puts the mean up very high whenever there's actually only 1 person who gets paid above that. So the mean, the median and the mode are all types of averages. So for that, the mean is normally the best one to use, but in this case it's not, because it includes everybody. But in this case, like, the manager bumps the mean up by loads because they get paid so much more than people like all those labourers. So saying that the average pay is 2,620, it's not a very good estimate, because there's only one person that gets paid more than that. All of these other people, 5, 6, 7, 8, 9 people get paid below that. Right, question 10 then. A cuboid is drawn on a 3D coordinate grid. You don't come across these very often. In fact, I think this is the only 3D coordinate question that I've seen in like the last 8 years or something. So it tells you here OC is 3 units, OA is 5 units, OD is 4 units, and then M is in the centre of the face D, E, F, G, so it's kind of floating up here. Then 10A, so which point has coordinate 3, 5, 0? If it's just a flat coordinate, like a 2D coordinate on a normal wee X, Y axis, the X comes first and then the Y. But now that it's 3 dimensions and there's another one added in, the Z goes at the end there. So that's X, that's Y, that's Z. So go to where X is 3, so go to X and go to 3. Go to where Y is 5, so Y is over there, 5 would be out there, so that brings us to here. And then Z is 0, so that means you're not going up any, so it's point B there. So 3, 5, 0, you go 3, 5 and don't go up any. So that one's B. Then part B, the numbers 3, 4 and 5 form a Pythagorean triple because 3 squared plus 4 squared equals 5 squared. They're just using a wee Pythagoras triangle here. So it would look something like that. 3 squared is 9, 4 squared is 16, add them together gets you 25, square root it gets you 5. So they're just talking about this wee triangle here working when you use Pythagoras' theorem. Which other point apart from A is 5 units from O? And circle the correct letter. So which other point apart from A is 5 units from O? So if we go back up here, there's O. You know that A is 5 units along because you can see it clearly. So they're wanting you to use this triangle. So go 3 across would be there, and 4 high would be there, which would mean that that would be 5. And there would be your right angle down in the corner there. So it's G for that one. A wee bit awkward. Not really very straightforward at all, that one. And then 10C, work out the coordinates of the centre M of the face D, E, F, G. So you need to work out half of X, halfway across Y, and then the full way up Z to get that one. So half out across X, so you're going, X is 3 across, so you're going 1.5 out, then 2.5 in, and 4 up. So halfway across X, halfway across Y, and then the full way up. So you end up with 1.5, 2.5 and 4. Again, a wee bit awkward for that one. Those the 3D coordinates. It's kind of one of those ones, either you see it or you don't. Number 11. Lauren puts £600 in a bank account. The account pays 3% compound interest each year. After 1 year she withdraws £200. How much will she have in the account after 2 years? So the first year, so 3% compound interest, and this is all without a calculator, so you can't use like 1.03 to put it up. Well, you could, but it wouldn't be the easiest way if you don't have a calculator. So I would find 1% of 600, so £6, and then multiply that by 3 to get 3%, would make that £18. So then the total after the first year would be 600 plus the interest of £18 puts it up to 618. And then after 1 year she withdraws £200. So £200, take that off the 618 to get you 418. So that's what she has after she has got the interest added on for the first year and she takes out the £200. So the second year then she's starting off with £418. So second year then 1% of 418 would be £4.18. You just go back 2 and put a point in or divide by 100. And then 3% would be 3 times that. So I just did a proper sum there, multiplying that by 3. So £12.54. So then the total in the bank account would be the 418 and then plus the £12.54 interest that you earned that second year, and total those up £430.54. Okay, so 3% compound interest just means 3% the first year, and then you have a big amount that you start off with the second year and get another 3% on top of that. It's the better one, simple interest. It doesn't keep building up and building up. You get it for the first year and then it just stays the same after that then. So 3 marks for that. You would get a mark for this bit, a mark for taking off the 200, and then a mark for this bit and adding it on as well. Number 12. So here are 6 rods. The 2 longest rods are the same length. So those 2 there are the same length. And then these ones here, it looks like they're gradually getting smaller. I labelled them A, B, C, D, E, F just to make it clear which one I was talking about. So the 6 rods can be fitted together to make a quadrilateral with equal sides. Use algebra to show clearly how this can be done. So the 6 rods can be fitted together to make a quadrilateral with equal sides. So it said to you that these 2 here were the same length. So I started by putting those 2 equal to each other. So down here, put them equal to each other, multiplied out the brackets. So 2 times 2x is 4x, 2 times 1 gets you the 2. And then this one, there was no number to multiply it by in front, so it just stayed as it was. And then I solved it by bringing the 2x over here and taking it off, the plus 2 over there and taking it off to get 2x equal to 5, so then x equals 2.5. So if you do that then, you're able to substitute x back in to all of these to work out what length they all are. Okay, so I did that, worked them all out. So A and B are the longest sides, so putting x equal to 2.5 in there gets me 12. Then I worked out what C was, worked out what D, worked out E, worked out F, and then said that you could have had 4 sides that are 12 centimetres long because those 2 there are both 12. So you could have like 12 and 12 there for A and B. And then you can put C and F together would get you 12 because it's 8 and 4. So down here you could have 8 and 4 for C and F. And then down at the other side, D and E also make 12, so 6.5 and 5.5. So 6.5 for D and 5.5 for E. And then you'd end up with a quadrilateral where all the sides are 4, and that's what they were looking for, because it said a quadrilateral with equal sides and for you to show how it could be done. So the key to that question was this bit here, where it told you that the 2 longest rods are the same length, because that was your starting point, putting those 2 equal to each other. Solve it, work out what x is, substitute it back in and work out that it could be 12 for each side. Question 13. Write this number in standard form. So standard form is whenever you've got a number here between 1 and 10 multiplied by 10 to the power of something. So the number that you pick out there is 7, and because this is a small number, your power here is negative. So 7 multiplied by 10 to the power of minus 7 actually means divided by 10 7 times. So if you have 7, the point would be like after that, and go back 1, 2, 3, 4, 5, 6, 7 to get where that point is. So that's it written in standard form. This one, write 3 times 10 to the power of 5 as an ordinary number. That just means multiply by 10 5 times. So 3 then multiplied by 10, 10, 10, 10, 10, just puts 5 noughts on it. Just 1 mark for each of those, don't really have to show any working out or anything. Part C, work out this and give your answer in standard form. The easiest way for you to do this without a calculator would be to multiply those two numbers together and multiply the 10s together. So multiplying the 4 by the 8 gets you 32. Multiplying the 10s, the rule there whenever you're multiplying when you've got the same base number, when you've got the same 10, is for you to add the powers. So add the 3 and the 5 to get the 8. So 32 times 10 to the power of 8 is what I've got here. But it said for you to give your answer in standard form. And that's not properly in standard form just because the 32 is too big. So the 32 would have to go down to 3.2. And because you're putting it down 1, you have to go over here and put the power up 1 to make up for it. So the 32 goes down to 3.2 and the 8 goes up to 9, and then that would be your final answer. Quite a nice question there in standard form, there's nothing too difficult there. Right, question 14. So 6 cups of tea and 4 cakes cost £13.20, 5 cups of tea and 4 cakes cost £12. Is £10 enough to buy 3 cups of tea and 4 cakes? So the only difference between these two numbers here is the only difference between what they've bought, if you treat this like two separate people, and that's what the first person's bought and that's what the second person has bought. They've bought the same amount of cakes. The difference between what they bought was a cup of tea, and the price difference is from 12 up to 13.20 would be £1.20. So that tells you it must be £1.20 for a cup of tea. If you don't notice that, then I don't really know how you would do the rest of the question. You need to compare those and realise that these are the same, these aren't. 1 cup of tea, £1.20. So then use either one of these, either the first person or the second person. I chose the second person because I thought the £12 would be easier to work with and the 5 cups of tea is smaller. So easier to work with without a calculator. So if 1 cup of tea is £1.20, 5 cups of tea would be £1.20 times 5, so that's £6 for the 5 cups of tea. So then take the £12 here and take off the £6 for the cups of tea, leaves it as £6 for the 4 cakes. So 12 take away 6 means it's £6 for the 4 cakes. And then you're wanting to work out, is £10 enough for 3 cups of tea and 4 cakes? You don't need to work out how much it costs for 1 cake because it's all to do with 4 cakes, so I wouldn't bother doing that. You've worked out that it's £6 for 4 of them, so that's okay. You just need to work out what the price would be for 3 cups of tea. So again, 1 cup of tea is £1.20, so 3 cups of tea would be £1.20 times 3, so that's £3.60. Plus on the £6 for the 4 cakes works out at £9.60, so yes, £10 is enough and have 40p left. And you would need to show all of this working out to get your 4 marks. You need to show exactly where you're getting the price for the cups of tea, how you're using that to work out the cakes, what you're doing to work out how much they're going to spend. You need to actually say yes at the end as well, because they're asking you a question, so you need to say yes or no. Number 15. Rearrange this formula to make x the subject. So that means change the formula about so that x is on its own at the minute y is on its own. So the first thing you need to do, the bit that makes this look really bad, is the fact that it's a fraction. So the first thing that you would need to do is get rid of the bottom of the fraction. So bring the x plus 1 up over here and multiply by it, because over here that means divide by x plus 1. So bring it over here and times by x plus 1. So get rid of the fraction, multiply y by x plus 1. And then you've still got the 3x minus 2 on the other side. So that's the first step, get rid of the fraction. Then you would need to multiply that out. So y times x, yx, y times 1 would get you y. You could have xy here instead of yx, it doesn't matter. Or on the far side, nothing to multiply out, it stays as it is. Then you need to get all the x's together. So it's looks a wee bit like solving an equation here, but you don't actually get a proper answer. So to get all the x's together, you need to bring that 3x over here and take it off. You need to get rid of that y, so the plus y goes over there and it gets taken off. So over here on this side you've got yx take away 3x, and over here you've got minus 2 take away y. then you would need to factorise, because you're wanting to make x the subject, so you need to get x out on its own. It can't be in here with a y and a 3 beside it. So factorise and take out an x. So x goes out in front of the brackets, and then inside you'd have y take away 3, just working backwards. The x times the y would get the xy, the x times the 3 would get the 3x. So that's it factorised, and the second side stays as it is. Then for you to get the x on its own, you need to get rid of the bracket here, and the bracket after the x means multiply. So bring the y minus 3 over here and do the opposite of multiplying, so divide. So you end up with this on the top and this on the bottom, just written as a fraction. And then that would be your final answer down there. There is some stuff that you can do messing about with the minus numbers to make it look a wee bit nicer, but you don't have to do it, so I wouldn't bother. Just leave it with all those nasty looking minuses in it. So 4 marks for that one. You pretty much get a mark for each step as you go along. So a mark for getting rid of the fraction, a mark for expanding and getting your x's together, a mark for factorising, and then a mark for getting the actual fraction at the end. And you have made x the subject, you've got x on its own. Question 16. So the table and histogram show some information about the cholesterol level in the blood of 100 patients. So a histogram is a bar chart, but instead of having frequency up the side, it has the frequency density up the side. So the frequency density is the frequency divided by the class width. So this number, the frequency, divided by how big the gap is from here to here. So first thing they want you to do is use the table to complete the histogram. So the histogram, the bars that were missing, this one here was missing between 2 and 3. So between 2 and 3, the frequency was 13. The class width between 2 and 3, the gap there is 1. So just 13 divided by 1 is 13. Nice numbers there. And go down and draw your bar up to a height of 13. The next bar that was missing between 4 and 5. So in the table between 4 and 5, 19 was the frequency. The class width is just 1 again between 4 and 5. So 19 divided by 1 gets you 19. And back down here and draw a bar that goes up to 19. Then the other bar that was missing between 7 and 10, so the frequency there was 15, divided by the class width here is 3, between the 7 and the 10 is a gap of 3, so 15 divided by 3 to get the 5, and go to the bar at the end there and draw it up to a height of 5. These bars aren't the same width, because it's not just a normal bar chart or a frequency diagram, it's a histogram. So they're all shoved together and they're all different widths. So that's the first bit done, that's the histogram completed. They also wanted you to use the histogram to complete the table. So the numbers that were missing in the table were for those 2 bars there. The first one was filled in for you. So these 2 here, the bar between 3 and 4 goes up to a height of 17. So that means the frequency density is 17. Between 3 and 4, so between 3 and 4 the frequency density was 17 and the class width is only 1, so that means that this number here for the frequency has to be 17, because 17 divided by 1 would get you the 17. The other one that was missing then was the 5 to 7 bar. So if you go down here between 5 and 7, that bar went up to 14, so the frequency density was 14 for that one. So in the table, if the frequency density is 14, the class width is 2, because it's going between 5 and 7 there. That's the gap between 5 and 7. So it has to be 28, because 28 divided by 2 would get you the 14. So that's that question done then. You've filled in the whole table and you've completed the histogram. They gave you quite nice numbers there. There was nothing too difficult. Number 17, OAB is a sector of a circle, radius 12, so it's just a slice of a circle like a pizza slice or something like that. And the radius is 12, so that is your radius, from the middle out is your radius, and they tell you that this is 60 degrees. Work out the length of the arc, so they're wanting you to work out that length there. So if you're working out the length of the arc, you would use the formula for the circumference, because the length is a bit of the perimeter and the perimeter of the circle is the circumference. So C equals pi times D. So you would do pi times 24, because if the radius is 12, the diameter would be double that, so it would be 24. And it said give your answer in terms of pi because you don't have a calculator. So pi times 24 you just write as 24 pi for the full circle. But it's not a full circle, it's only 60 degrees. So I then did the 60 degrees out of 360 for the full circle. Simplified that down means it's 1/6 of a full circle. And then just take the circumference of the full circle and divide it by 6, because that's how you find 1/6. And then 24 divided by 6 gets you 4, and then stick the pi after it again, so 4 pi. They didn't ask you to find the perimeter there. If they did, you would need to add another 24 on at the end, so you would just have 4 pi plus 24. But they were nice there, they just asked you for this wee length of the arc, which is just 1/6 of a full circle, so full circle, divide by 6, done. Only worth 2 marks, that question as well. So you would just have a mark for the 24 pi, and then a mark for dividing it by 6 and getting the 4 pi. Right, number 18. Solve that equation equal to naught. Give your answer in the form this, where a and b are integers. So they've given you a pretty big clue there by giving you this wee bit here, which should make you think of the quadratic formula that's given to you at the start of the paper. So go back to the start of the paper, write down your formula, get your a, b and c. So a is the number at the start in front of the x squared. If there's no number there, that means a is just 1. The next one, the next number that you come to in front of the x, that's your b, so b equals 6, and then the last one is the c, so c equals 2. So a is 1, b is 6, c is 2, and I've just copied that down there. And then you just go along and use some substitution. So instead of minus b, it's minus 6, plus minus square root. Instead of the b squared, it's 6 squared. Instead of the 4ac, it's 4 times 1 times 2. And then all over 2a would just be 2 times 1. Normally you would need a calculator for this, but they've given you nice enough numbers because it's a non-calculator paper. So minus 6 plus or minus square root. 6 squared is 36. 4 times 1 is 4 times 2 is 8. And then on the bottom, 2 times 1, 2. Then you can do the 36, take away the 8 to get you 28. So we've got it to this stage. But that's not how they want it left. They don't want it left with the wee over 2 on the bottom. They want it just as a something plus or minus the square root of something. So I then took the root 28 and used surds to simplify it. So root 28, split it up into 2 roots, one that you know, one that you don't know. So 4 sevens get you 28. So then you know that the square root of 4 gets you 2, and then you just leave the root 7, so 2 root 7. So I replaced the root 28 with the 2 root 7, so then I could divide everything by 2. So minus 6 divided by 2 gets you minus 3, and then 2 root 7 divided by 2 gets you root 7. And now it's in the form that they want, so that would be your final answer there. The minus 3 plus or minus the square root of 7. You can't just do, at this stage, root 28 divided by 2 gets you root 14. It doesn't work like that. Okay, the 6 divided by 2 gets you the 3, okay? But you can't just do root 28 divided by 2 gets you root 14. It doesn't. If you don't believe me, check in your calculator. You need to use surds, simplify it down to get the 2 root 7, and then divide it by 2 to get you root 7. Right, question 19. So B, X, Y and Z are points on the circumference of a circle. So B, X, Y and Z. A, B, C is a tangent along the outside of the circle, and then BX is parallel to ZY. So they're telling you these two lines here are parallel, these two here. Work out the size of angle ZXY. So ZXY is that one there, going from Z to X to Y. So this one here is the one that we are looking to find. And you have to show your working out, which may be on the diagram. So the first thing I did was use the alternate segment theorem. So using that big yellow Z, which moves that 30 right up to that top corner, not in there. That's like the normal Z rule where the top and bottom are parallel, and they're not in that picture. Okay, so that's the alternate segment theorem, copies that 30 up to there. And then I just wrote down here that that's what I did. But they said it was okay just to have it in the diagram, so 30 from there up to there. Then I used the green lines here, just the normal alternate angles where the top and bottom of the Z are parallel, and that copies that 30 over to there then. And I wrote it down here as well in the answer space. After that then I used the, I don't know what I've written down here. After that then I used the cyclic quadrilateral angle. So used the 70 here and said that the one opposite that, so using that big quadrilateral there, those two angles have to add up to 180 because that's the rule. So that one's 70, that one's 110. And then after that I just used this wee triangle and did 110 plus the 30 is 140, take it off 180, get you that one there is 40 then. And then that would be your final answer. It said that you could do all the working out in the diagram, but I did write down here just what I did, that I used the cyclic quadrilateral, that I used the triangle, got the answer 40, and then put it down there. Number 20, circle the value that is equivalent to this. So surds again then. So root 50. Pick a root that you know and a root that you don't know. So 25 times 2 gets you 50, and use the 25 because you know the square root of that is 5, and then copy down the root 2. Then 32, you could use 4 and 8, but then the root 8 would need to be simplified down further, so choose the biggest one. So choose the 16 and 2 instead. So root 16 gets you 4. Remember, you have to choose one that you know and one that you don't know. So the root 16 you know is 4, and then you copy down the root 2. And then whenever you add those two together, 5 root 2 plus 4 root 2 gets you 9 root 2. So that's your answer there for that one. Then circle the value that is equivalent to this. So whenever you're dividing, you can just do 4 divided by 2 to get the 2. The root 75 divided by the root 3, you can divide those because they've both got roots, would get you root 25. And then root 25 is 5, and then 2 times 5 would get you 10. So that's the answer for that one. Just one mark for each of those, just for circling the right answer. Number 21. Given that, this, work out the value of x. So I kept the 3 to the power of x as it was. I went over here and changed this one. I changed the 9 into 3 squared, because what you're going to have to do here is compare the two powers. So you can't compare the powers if one of them has a base of 3 and the other one has a base of 9. You would need this to have a base of 3 as well. So change the 9 to a 3 squared. So the 9 replaced with the 3 squared, and then you've still got the x plus 1 there. So that means now that you've got the same base here, you can just compare the powers. So that means that x is equal to this. So put them equal to each other, expand that bracket, 2 times x, 2x, 2 times 1, 2, and then solve by getting all of the x's onto one side. So you would need to bring the 2x over here and take it off. So x take away 2x gets you minus x, and then you've just got the 2 there. So if minus x gets you 2, that means x must be equal to minus 2. So that's it. It's just like solving equations, but you need to put the powers equal to each other and turn the 9 into a 3 squared first. And that's it. That's the end of all of the questions.